In this lesson, we are going to review the metric system, the units, the prefixes, and the conversion fractions. And we're going to use those conversion fractions to help us convert between units. So first off, what we need to recognize is what we have available to us in our reference tables. We have reference table C with selected prefixes, and we have reference table D with selected units. These are considered base units, right? So you can have the base unit of meters. We can stick prefixes on them and to get different versions of that particular unit. So you can have kilometers, or you can have millimeters, right? So these are what are considered the base units. Now this reference table C is what we're going to focus on here. It's helpful, but it's actually lacking some things. So the first one that we see is 10 to the third power. This, of course, is the kilo with a symbol K. The expanded factor of 10 to the third just means it's 1,000. Okay, kilo is 1,000. 10 to the 3 is 1,000. What they are missing here is, notice that 10 to the third is the only power of 10 that is greater than, it's greater than 0, right? This is a positive number. All these others are negative exponents, which means these are prefixes that represent smaller than 1. So let's take a look here. What we're going to do is we're going to stick in right here, if you wanted to draw this directly onto your reference tables. There really should be a factor of 1 here. There is no prefix. It is the base unit. Okay, this is the base unit. Okay, it doesn't have an expanded factor. It doesn't have a prefix. But this would be like grams or meters, where if here you're talking about kilograms or kilometers. So the base unit has no prefix. Okay, it has no prefix. Let's take a look at the remaining ones. 10 to the negative 1, right, is 1 over 10, which is equivalent to 0.1. The prefix here is deci. And the symbol that we would use for it is D. This is not a very common one that we will use, but there it is. 10 to the minus 2 is 1 over 100. It is the same thing as 0.01. This is a centi, is the prefix, and the abbreviation for that prefix is C. 10 to the minus 3 is 1 over 1,000, which is 0.001. This is a milli, is the prefix, and the abbreviation for that is M. 10 to the negative 6 is 1 over a million, right? 1 over a million. So that is 0.0000001. I believe that is correct. 1, 2, 3, 4, 5. Yep. This is a micro is the prefix, and the abbreviation is the micron symbol, or the mu, Greek letter mu, which is a U with a little tail in front of it. 10 to the negative 9 is 1 over a billion. It's a 1 with 9 zeros over it, equivalent to 0.00000. That's 8 zeros after the decimal, 1 zero in front of the decimal. This is what is called a nano. That's the prefix of nano, with the abbreviation for that prefix being an N. 10 to the negative 12 is 1 over a trillion. 3 more, so 12 zeros right there, 1 followed by 12 zeros. And of course, that's going to be equal to 0.12 total zeros there, 0.11 zeros and a 1. Obviously, that's not a very practical number, but this prefix is called a pico and has the abbreviation for that prefix being P. Okay, so the most useful thing you can recognize is that there's this pivot that when you have a positive exponent, that's going to be a prefix that is larger than a base unit, and everyone else with a negative exponent is a prefix that is smaller than 1. So for prefixes that are larger than the base unit, we are going to set up what's called an equality. And what we're going to say here is that and we're going to use the base unit example we're going to use here is the meter. Okay, we're going to use that for our base meter example. So if we say that we have 1 kilometer, right, 1 km, that is equal to how many base units? So that's going to be equal to 1,000 meters, which has an abbreviation of M. 1 kilometer is equal to 1,000 meters. So we can turn that into a conversion fraction, which we'll explain why we're going to need this later. But if you said 1 kilometer over 1,000 meters, those two values are equal to each other. So this conversion fraction is equal to 1. Or even if you flipped it, if you said 1,000 meters over 1 kilometer, that fraction is also equal to 1. Because these are equalities, this number is equal to this number, this fraction is equal to 1. And that's going to become really useful when we do metric conversions here in a little bit. So let's talk about what do we do for equalities where the prefix is smaller than the base unit. Let's take centi, for example. Now I'm going to say that 1 meter is equal to 100 centimeters. Right? Centimeters is cm, meters is m. 1 meter is 100 centimeters. Okay? We know this because centi means 100. And so you can have 1 centimeter over 100 centimeters over 1 meter. That's a fraction that is equal to 1, or 1 meter over 100 centimeters. So we're going to take equalities and turn them into fractions that are equal to 1. And you can flip them either way, and they are still equal to 1. We can also say that 1 meter is equal to 1,000 milliliters, abbreviated as mm, and we could use the fraction of 1,000 millimeters over 1 meter, or 1 meter over 1,000 millimeters. You want to get familiar or comfortable with being able to take those equalities and writing them as conversion fractions. Let's do one more. Let's take 1 meter is equal to 1 million micrometers, tomato. So that's the abbreviation UM. And this conversion fraction would look like 1 million micrometers over 1 meter, or 1 meter over 1 million micrometers. Okay. So the idea here is that we can take an equality and we can write it as a conversion fraction that is equal to 1. All right, so let's take a look at some of these conversion fractions and how we're going to use them in a technique called dimensional analysis. If you are being asked to take a measurement and convert it into a different unit, for example, millimeters, converting it to meters, there's going to be two methods that I'll show you. The first one is what we call dimensional analysis, and this is the method to use when you are asked to show your work. You are asked to show your work. All right, so what you will do here is you have to first know what your equality is. Okay, so figuring out what the equality is. What we know here is that the bigger unit is a meter, and 1 milliliter is smaller than 1 meter. So I'm going to say that 1 meter is equal to 1,000 millimeters. Okay, 1 meter is larger than 1 milliliter. So I started out by saying 1 meter is equal to, and then I know that milli means 1,000. So this is 1,000 millimeters. So using that equality, hang on to that for a second. You're going to go back to your problem and you're going to identify what's the number you are trying to convert. We are trying to convert 150 millimeters, and I'm going to use the abbreviation here. And you are going to set up a multiplication sign and then a blank fraction. And this is going to be our conversion fraction that uses this equality. And the question is, we can make a fraction where either meter is on the top or meter is on the bottom. The fraction could either have millimeters on the top or millimeters on the bottom. Okay? But recognizing that this number is really millimeters over 1, if I set up this fraction to multiply by a conversion fraction, I want to set it up so that millimeters is in the denominator of my conversion fraction, so that when I multiply, this millimeters is going to cancel with this millimeters. So I know that meters has to go on top, and I know from my equality that 1 meter is 1,000 millimeters. So now, doing this problem, we can recognize that millimeters over millimeters is going to cancel. The only unit left over that doesn't cancel is meters. And now it's just a matter of plugging numbers into your calculator, right? And maybe you can do this in your head, but 150 divided by 1,000 is going to give us 0.15 meters. Notice that I had 2 significant figures to start with, and so my final answer can only be reported to 2 significant figures. The unit that I write here on my answer has to be the unit that is left over, that did not cancel. All right, let's take a look at another example here. Now we're going to convert 6 liters to milliliters. So let's stop and think about what the equality is, right? We've got 1 liter. If we talk about liters to milliliter, if you talk about 1 liter versus 1 milliliter, 1 liter is bigger, and milli means 1,000. So 1 liter is going to be equal to 1,000 milliliters. And so keeping that in mind, that's going to go into our conversion fraction. So let's first set up the problem. The number that you are given that you have to convert is 6 liters. I'm going to multiply that by a conversion fraction where liters is in the denominator and milliliters is in the numerator. I know that 1 liter is 1,000 milliliters. Notice this time that compared to the first problem, I was dividing by 1,000 in the previous problem. This time I'm going to be multiplying by 1,000. Liters over liters are going to cancel, and my final answer is going to be 6,000 milliliters. Notice I had 1 significant figure to start, and notice I have 1 significant figure reported in my final answer. The next problem, I've got 150 picograms. I'm going to abbreviate that as PG, and I'm going to convert that to milligrams. So here we have an interesting problem because where in these first 2 problems, the 2 units that we were looking at, one of those units had a prefix, but the other unit did not. One of these units had a prefix, the other did not. But in this problem, if we compare the 2 units, they both have a prefix. So in this case, you're going to need 2 different equalities. And each equality is going to be compared to the base unit. So if we're talking about equality of picograms, if you recall, picograms is 10 to the negative 12, right? So that means that 1 gram is equal to 10 to the 12th, which is a billion picograms. Okay, you can write that out as 10, that's 10 to the 9th. Got to count these days. Okay, so you can write this out as 10 to the 12th, or you can leave it out as an expanded number, whatever works for you. So the equality number 1 and equality number 2 is where 1 gram is equal to 1,000 milligrams. So the idea here is that both of these prefixes, I'm going to write a separate equality statement comparing that prefix to the base unit. So setting up my problem, the original number that I'm trying to convert is 150 picograms. I'm going to set up a conversion fraction. The first conversion fraction, I want to get rid of picograms. So I'm going to put picograms in the denominator. And I know from my equality, picograms to grams, right? 1 gram, and then 1 times 10 to the 12th picograms. Okay, that's 10 to the 12th. Okay, so if I stop there, if I stop and did the math here, I'm not going to do it just yet. Picograms cancel, and I'm left with grams. But the problem wants me to go to milligrams. So I'm going to set up a second conversion fraction. Now, since I'm left over with grams, I want grams to cancel out, so I have to write this next fraction with grams in the denominator and milligrams up top. I know that 1 gram is 1,000 milligrams. And now I'm going to see that my grams will cancel. The only unit left over that hasn't canceled is milligrams. So now, in the calculator, we're going to have 150. I'm going to divide by 10 to the 12th. Okay, so I'm going to put that in as scientific notation. This is 1 times 10 to the 12th power. And then I'm going to take that answer and I'm going to multiply by 1,000. My final answer here is quite a small number. I'm going to force my calculator to put this into scientific notation. And I get 1.5 times 10 to the negative 7 milligrams. Next problem. Similar situation. I'm going from millimeters to nanometers. Okay, so I want to start with 1.34 millimeters. And before I do my equalities, I'm going to set up my fractions. I know I'm going to have 2 fractions because both of my units have prefixes on them. The first fraction, I want to get rid of millimeters, and I want to convert it to meters. The second fraction, I'm going to want to get rid of meters, and I'm going to want to go to nanometers. Okay, so that way, if I set up, sometimes it's helpful to set up your problem without the numbers in. So now we just have to figure out what our equalities are, right? So 1 meter has 1,000 nanometers. And 1 meter has 1 billion, 10 to the 9th, nanometers. Okay, so if you know those equalities, that's how you can use those quite readily to set up your problem. So here we're going to have 1.34. I'm going to divide by 1,000, because 1,000 here is in the denominator. And then I'm going to multiply by 1 billion. And you could use scientific notation for this. We need our final answer to have 3 significant figures. If I put this into scientific notation, I'm going to get 1.34 times 10 to the 6th nanometers. All right, so that is how you are meant to show your work if you are asked to show your work. You need to show why you can cancel out millimeters, because this millimeter unit is in the numerator, this millimeter unit is in the denominator, therefore they cancel. So showing your work oftentimes means you are showing or justifying how units cancel out. But there's another method, which I like to call the BS method, which stands for the big small method. What did you think it meant? But here's the basic idea, is that if your unit is going from a smaller unit to a bigger unit, so if your unit is getting bigger, then the decimal must move in the way to make the number get smaller. It has to offset it. Vice versa. If your unit is going from a big unit to a smaller unit, then the decimal is going to have to move in a way to make the number larger. Okay, so let's see how you can put all that together. Let's take a look here. Converting 150 millimeters to meters. If we take a look at our reference table C, going from millimeters to meters. Well, first of all, you have to recognize that as you go down here, the units gets smaller. Okay, so if we're going from millimeters to meters, remember going up to the base unit all the way across here, this is the base unit. So in this case, our unit is getting bigger, millimeters to meters, right? 1 millimeter compared to 1 meter. 1 meter is definitely bigger. So our number is going to have to get smaller. And the question is, by how many decimal places? Well, look at your exponents here. 10 to the negative 3 up to the base unit, which has an exponent of 0, that's a total of 3 decimal places. Okay, 3 decimal places. Millimeter from reference table C is listed as 10 to the negative 3, and a meter is the base unit, so it has a 10 to the 0. That's a total distance of 3 decimal places. So we need to move this number, we need to make the number smaller by 3 decimal places. So from 150, the decimal was here, we have to move it to be 0.15 meters. 1, 2, 3. We've moved it 3 decimal places. We've maintained 2 significant figures. This was 2 sig figs, this is 2 sig figs. All right, what about converting 6 liters to milliliters? Okay, so liters now is the base unit, right? If you're at the base unit and you're trying to go to milliliters, now we're trying to go down, right? So now the unit is getting smaller, so our number is going to have to get bigger, again by 3 decimal places, right? Because milli is 10 to the negative 3, and the base unit is 10 to the 0. That's a difference of 3 decimal places. So that means 6, which was 6 point, now becomes 6,000. And that's going to be milliliters is the unit. So notice so far, we're getting the same answers that we got up here. We're just taking a little bit of a mental shortcut here. So let's take a look at what happens when we have both of our units with prefixes. We've got picograms and milligrams. Now pico, according to this, is 10 to the minus 12, and milli is 10 to the minus 3. That's a difference of 9 decimal places. So that's how many decimal places we're going to move. So which way are we going to have to move it? Well, picograms to milligrams, our unit is getting bigger. And if our unit is getting bigger, our number is going to have to get smaller. So if we move this decimal 7 places to the left, right, 150, 1, 2, 3, 4, 5, 6, 7. If you want to manually do it like that, that can work. So that would be 1, 2. I'm wondering if we did that wrong. 10 to the negative 12, 10 to the negative 3. Oh, we got to move it 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's 0.000 000 1, 2, 3, 4, 5, 6, 1, 5. There it is. And that will be in milligrams, right? That's the same thing as 1.5 times 10 to the negative 7 milligrams. Either one of those is correct. All right, how about this one? 1.34 millimeters to nanometers. Millimeters is 10 to the negative 3, according to this reference table C. Nanometers is 10 to the negative 9. The difference between those is 6 decimal places. So the question is, which way are we going to move the decimal? Right? So let's take a look. We're in millimeters. We're going to nanometers. Millimeters to nanometers. Our unit is getting smaller, so our number is going to get bigger by 6 decimal places. So we want to move that decimal 6 places out. So we get 1,340,000. The unit here is nanometers. This is 1.34 times 10 to the 6th nanometers. Either way can be expressed. All right. So in this lesson, we're trying to make use of reference table C. We recognize that the base unit should really be marked in that so you understand how to generate equalities. So you can, from the equalities, you can generate conversion fractions. Conversion fractions are used in a technique called dimensional analysis, which allows you to take a unit, a measurement, and you can manipulate the units to give you an answer in the same value, right? These are the same magnitude values, just you've changed the unit. Okay. A note about significant figures. We do not let these equality statements factor into our decision for significant figures. Equalities are considered perfect and have unlimited number of significant figures. So however many significant figures we had in our original measurement need to be reflected in our converted values. All right, so this is how we convert metric units using the technique of dimensional analysis. That's it for this lesson. We'll see you back in the classroom.